We also follow a standardized way of doing things called defense in depth. Now, I've heard this term used a lot in DoD, market spaces. And it's the concept of, from soup to nuts, I'm going to build, maintain, and optimize using the concept of security at all levels, not just at the perimeter and not just at the data, but all the way through. And as I design my data centers, as I design my applications, I'm keeping my security context in mind so that it's easier to plug in. The compartmentalized approach is by far the best way to do it. Compartmentalized and modular. I want to be able to take pieces, change pieces without affecting upper layers. So the first premise of defense in depth is multiple, sometimes overlapping layers. If you have to think of a real-world thing that you can hold, think of an onion. It has multiple layers, with the center being the most prized piece. Narrow windows of access per layers. So if you've ever played that game that's got the ball in the maze and you have to keep twisting it and turning it to get it to drop down the appropriate chutes, imagine if that's your attacker. If every time he has to make an attack, he has to go down a narrow corridor or a narrow lane, the chances of him being picked out, his traffic being picked out and mitigated, are greater. Now, I'm not saying that you make this Byzantine labyrinth of security measures that makes your applications and your services hard to use. This is a juggling game. There's always that juggle between making the application user-friendly and making it secure. Somewhere in between is where you typically fall. But as long as you can identify the risks, you can take the proper steps to mitigate. Obviously, define your security, your defense in depth, with a high fault tolerance. Nobody wants that one firewall that goes out to the internet. That firewall goes down, I'm down. My users are going to complain because they can't get to Google, Facebook, and of course all their P2P sharing, which we know that we don't allow. Myself a victim of that. And you must always assume, as a good security practice, that the layer above you will fail. Now, that's not to say that at every single layer of my security architecture I'm going to have a firewall, but you have to understand that if you plan that it will fail, and it does, you're safe. If you don't plan that way and you fail, you're open. One of the key security risks that's been identified in 2009 has been in the virtualization space. So everyone is doing virtualization these days. And at first, the concern was, at the hypervisor level, since all of my VMs are being controlled at that level, what happens if that hypervisor gets cracked? If in some way it is held hostage, all of my associated VMs with that hypervisor are at risk. So what has been found out over time, the last year or two, is that the hypervisor, being a very thin shim in the operating stack, is not that susceptible to attack. With that being said, there's a whole lot of tools that you can use at the virtualization level, the virtual machine, to prevent the attack at the virtual machine level and at the hypervisor level. So where you have the security VM features, which is centralized network protection, this is basically your zoned firewalls. This is HIPS loaded on the host device. This can also be a NAC product, be it Cisco NAC. The end result is that with the explosion of virtual machines and the server sprawl that it causes, I don't want anyone creating machines that I don't have control over. I have to find a way to, one, authenticate that machine to make sure it's a valid machine, that all the patches and policies that should be in place in that machine are there, and that it's actually needed to be added to a specific VLAN in that network. NAC control will allow you to do that at the host level. Policy-based MAC is a similar sort of issue where I'm controlling what VLAN that machine can attach itself to. And also the network protection, where we're talking about the IPS and firewall, which is either integrated in with the machine or resident on the network. The hypervisors are typically protected by what's called TPM, Trusted Platform Module. So what this allows us to do is verify that that hardware, that hypervisor, is being loaded at a very basic functionality set and that is not susceptible to attack.